Good afternoon, everyone. Welcome to Global Compliance Panel's live webinar on Statistical Process Control and Trending Analysis. My name is Sam, and I'm going to be your host today. On behalf of the Global Compliance Panel team, I would like to thank you for being part of this event. Today's webinar will be presented by Stephen Wolfish. Mr. Wolfish is the president of Statistical Outsourcing Services, a consulting company that provides statistical analysis and training to FDA-regulated industries. Prior to starting Statistical Outsourcing Services, Mr. Wolfish was the Senior Manager of Biostatistics Non-Clinical at Human Genome Sciences in Rockville, MD. Before joining Human Genome Sciences, he was a Senior Associate at PricewaterhouseCoopers, specializing in the pharmaceutical industry. He was a Manager of Non-Clinical Statistics at Chiron Diagnostics. Mr. Wolfish brings over 20 years of industrial expertise in the development and application of statistical methods for solving complex business issues, including data collection, analysis, and reporting. We are honored to have such a distinguished person such as Stephen Wolfish with us to present this webinar today. Before we begin, I would like to inform you of the program outlined for this training session. This webinar is for 60 minutes duration. First, Stephen will take you through today's webinar, highlighting the areas that will be covered, and he would then share with you his presentation. We would like to inform you that all participants, once part of the teleconference, have been placed on mute and will remain so until the Q&A window begins. It is for the purpose of avoiding discontinuity and for allowing the presenter to speak clearly so that everyone present can take maximum benefit from this webinar. We also request all to hold back your questions until the Q&A window begins. 10 minutes of time will be allotted for the Q&A, during which your questions will be answered. If for any reason you get logged out of this training session or teleconference, please follow the same procedure to join in again. Now that we are all ready to start, I request Stephen Wolfish to take it from here. Stephen?
Yes, thank you very much, Samuel, and hopefully everyone can hear me clearly. And as Samuel said, what we're going to be doing is going through over the next 45 minutes or so, 45 to 50 minutes, a little bit of an overview of some statistical process control and trending. And I'm going to spend more time really discussing the idea of trending more than I will of SPC. You can get almost any quality control textbook and see some of the concepts I'm talking about from an SPC perspective. The trending analysis, specifically in the medical device and pharmaceutical space, is probably a little bit more of what most people would like to hear about, and they'd like to see what is going on in industry and how different companies are dealing with trending analysis for different data types. So we'll spend some time going through and talking about that. All right, so we'll talk a little bit about run charts. Then we'll talk about control charts, both variables and attributes, using regression analysis for trending. And then the tail end of it, the last 10 or so minutes, we're going to talk about some unique issues in trending, and that should lead us into a very good discussion and question and answer period. Okay, so when one talks about a run chart, what they're really talking about is just plotting data over time. And as you see here, there is no statistical limits. There is no assessment of what is an in control, out of control, trend, or anything at this point. All we're saying here is that a picture's worth 1,000 words. I can look at my data over time. And what it allows you to do, and what is very natural for the eye, is to start to look for different patterns in the data set. And so you might see yourself with a situation, such as what you see, in this sort of general vicinity up here, where you're starting to see an increase in the data. And then everyone's eyes probably sees that. They might be looking here in this sort of region of data and saying, I'm starting to see a little bit more of a choppy data set. So what you want to be able to do is just take a quick assessment of the data and try to apply that visually. Now, once I take a run chart and I put in some sort of statistical limits, I start to put expectations on where my values should and should not be. And it allows me to start to look for things like excessive variation, or in SPC terminology, start to understand what a common cause variability and what special cause variability is. So let's take a look at this top chart here where we have an individual plotted over time, and we put statistical limits in. And I highlighted the two red dots. Those are two values that statistically we believe to be outside of the expectation. So the horizontal control limits, the horizontal limits that I put on my data set, within that is common cause variability. We expect that to be where most of my data will reside, and 99.73% of the data will be within those control limits. So the likelihood of being outside the control limits is about 3 in 1,000. So when we see a point like this, we tend to react to that and say that that is a special cause and that something must have changed in the process. And what you see in the bottom graphic is the range, and these are what is called the moving range. And we'll talk a little bit more about each of these each different type of control chart. But a moving range is just the absolute difference between two successive points. And so what we're really looking at is the variability. And as you see here, towards the end, we get a point outside of our control limit that says the range between two successive points is in excess of what we expect it to be, again, a special cause. And we tend to look at this and come up with a cause for why that occurred. And so that we're clear, this red point that we're talking about here is associated with the difference up here between what would be 0.70 and 0.71, where you see that we're going from a high value down to a lower value. So we're going from this value up here to that value down here. That absolute difference is that red point right there. Okay. So what I've been able to do is explain to you that statistically I can set up a set of control limits that differentiates normal common cause variability, inherent variability in my process, from special causes that are usually have some sort of assignable cause to it. So how can you detect a trend in the data? How do you know if that trend is even significant? Is a single point aberrant? Is there just one point that's bad, or is there several points? And then ultimately, is there too much variability? So we're going to talk about this as our theme over the next half hour to 45 minutes. Okay. So what I'm going to do is I want to make some definitions, and what I want to make clear to everyone is that when I say this is a trend, it is a trend in what I'm helping, or what I define to be a trend. Every organization is going to determine what they believe to be an effective trend, and I'm going to explain what I mean by that in a moment. So what I'm putting out there is that if I have 5 or more points in a row that are either increasing or decreasing in value, I'm calling that a trend. So if I go from 1 to 4 to 7 to 9 to 11, I say, that's 5 in a row that are increasing, that must be a trend. Likewise, if I get 7 or more that are sort of drifting in the same direction, they might not all be going increasing or decreasing. So I might get 1, 5, 4, 9, 11. And in a situation like that, it's not successive, but it's drifting up. And when that happens with 7 or more points, we call that also a trend. Now, when I use 5 and 7, those are based on some statistical theory, and they align themselves with an approximately a 3 in 1,000 chance of calling something a trend when in fact it's not. For your organization, you might want to take action faster or slower. So if you want to be a more reactive organization, which means that you're going to take action, maybe for things that are truly not a trend, you might say 4 and 6. If you're an organization that wants to delay taking action, you might say 6 or 8. As long as you document what you have as your definition of a trend, and in many cases you can actually go back and understand the theory behind it, that is fine. That is what you call a trend, and that works, well, you know, fairly good for you. As I said, you're going to find something that works for you because you have to use these rules on a regular basis. Another way of defining a trend is to look for 7 or more points on one side of the mean or the other. The probability of getting 7 points in a row to be either above the mean or below the mean is about 1% of the time. It's a little bit less than 1% of the time. Again, think of flipping a coin. If I got 7 heads in a row, do I believe that to be a fair coin, or do I want to look at the coin and say, maybe it's not a fair coin? Because I would expect that in 7 flips of a coin, I'm going to get a certain number of heads and a certain number of tails. Again, some other things, you're going to look for variability and cycles in your chart, and these are more eye tests. So the first 2 are more empirical values, and the next 2 are more about things that are eye tests, and they're a little bit harder to put into a procedure. So let me just show you what I mean by 5 in a row. Here we've got a graphic of complaints, and I have 5 months in a row where my complaints were increasing. I call that a trend. Here's a situation where I don't have 5 months in a row that are increasing, but I have 7 months where it's trending up. And so after the 7th month, I take a look. Now, I use complaints because we're going to talk about that later on. That's what a lot of people use trending for, is to determine when they need to take action. When is their trending, or when is their complaint rate out of control and needs to be taken action or investigation? 5 months in a row that are increasing, or 7 months in a row that are trending up. So take a step back and talk a little bit about the idea of a control chart. A control chart is a statistical chart that sets the limits at plus or minus 3 standard deviations. And there are 5 typical or common control charts that you will run into. One is an X individual chart with a moving range. One is an X bar chart with a range, an X bar chart with an S, a P chart, and a C chart. And what these charts do is they both measure the mean response, as well as they also measure how much variability I am seeing in the data set. So we'll talk about the first one, which is the X moving range chart. This is when I only have a single observation at a given time point. So you can imagine if you were collecting number of complaints every month, you only have a single number every month, and you want to do some sort of analysis. Again, a time point could be a lot, could be a batch, can be a lot of different types. Like I said, a complaint, it can be number of non-conforming lots, but however you want to look at it. Again, in a moving range chart, as I said to you before, the variability is assessed by looking at consecutive points and the variability amongst consecutive points. And typically, you'll see this theme throughout the presentation. You need at least 20 time points or 20 data points to set up these control limits. Now, the formula is very straightforward. It's just X bar plus or minus 2.66 times the moving range average. The control limits on the moving range chart is 3.267. Again, you can go to any quality control textbook, find these formulas, find examples of this method. Here is a typical X moving range chart of weight, and so you see that I have, in this case, 40 points, and I have the green line, which is the average weight here, 54.98, and statistically, I say that based on the variability that I'm observing, a particular weight for any particular lot. Could be anywhere from 38.61 to 71.34. The bottom chart, the moving range chart, gives, again, the range, the absolute value of 2 successive points. So there'll be n-1 total points. So in this case, there are 40 points on the top. There's only 39 points on the bottom. As you can see, point number 1 is missing. Again, you can look at the same thing for a trend. Again, we expect on average that successive lots will be 6.15 units apart. So on average, we could expect that if I see a lot that has 51, we can see on average the next lot be anywhere plus or minus 6.15 units. The next type of chart is an X bar and R chart. Again, here's where we are taking when we have more than one repeat value at a given time point. Typically, if it's less than 5, we use the range chart. In a minute, I'll show you the standard deviation chart. We use the standard deviation chart when the number of replicates is in excess of 5, and pretty much everything else stays the same as it does for the X moving range chart. Here, the formula is X double bar, so it's the average of the averages, plus or minus this A2 constant. I'll show you a table in a minute that defines the A2 constant times the average R bar. And the control limits for the range chart is D3 R bar and D4 R bar, and these constants are tabled in a minute. So if I took that same data set of weights and I bunched them up into groups of 4, you'll see here that when you do that, the third average of 4 weights is outside the control limits. That's why this particular graphic has a red dot there. And you see that the control limits are narrower because we're taking averages of the values, not the individuals, but the ranges look very solid. So this is an example of an X bar R chart. An X bar S chart, as I said, is when we get greater than 5 samples at a time point. Again, the formula is A3S bar, X bar plus or minus A3S bar, and then the range chart is B3S bar and B4S bar, and so the chart will look very similar to this. As a matter of fact, the control limits are very similar. The only difference is how we estimate the standard deviation. In one case, I'm taking the range of the 4 values, and in this case, I'm taking the standard deviation of the values. The next set of charts are used for attribute data. So a P chart would be used when we have percentages or rates. So if I wanted to do a control chart on my first pass acceptance, or if I wanted to do a control chart on anything like, let's say, purity, that's a percentage, or something of that nature, a P chart would be appropriate. The assumption of the P chart is that the sample size is equal at each time point, so that if I was going to assess the first pass acceptance, that it, pretty much each lot is pretty close together, so that if I'm looking at that, or said differently, if I wanted to do this by month, first pass acceptance rate per month, that the number of lots I manufacture in a month is approximately the same. It should be exactly the same typically, but if one month you have 30, next month you have 28, there's not a tremendous downside to just using the percentages and not worrying about the actual number. So let me show you an example of this, let me show you the formula for this, which is P bar plus or minus 3 times the square root of P bar times 1 minus P bar over N. P bar is that percent, so again, if I was to do first pass rate, and if I had a 90% average first pass rate, I would take 90% times 1 minus 90%, which would be 10%, and divided by N, where N is the number of observations that goes into the estimate of P bar. So as I said before, if one month I make 28 lots, next month I make 30, one month I make 25, what you can do is just take, instead of having what N would be, you can put the average N that you see. Now there's something called an NP chart that actually allows you to plot the values where N is changing every month, or what a lot of people will do is they will calculate a new control limit every month based on the N. So it's up to you. I tend to like to use N bar, but some people like to use the actual N and get what are called stair-step limits. Okay, so here's a P chart of yield. Here's an example where the average yield is 73.17, and in this case, we actually have a particular lot that was in excess of my expectations. So based on what I've seen historically, 73.17% average yield. I'd expect to see as low as 57.8% and as high as 88.5%. In this case, I actually got a lot that was over 90%, and it's out of the statistical limits. And I use this example because most people would say, well, what's the problem, Stephen? We actually have a lot that is doing better than what we would expect. What's the problem? The problem is we should probably look into what we did in that lot and why our yield was so good. The fact is that trending is for both looking for bad things, like when our quality is dropping off, but it's also an opportunity for us to look at when things occur that are statistically not very common, that are beneficial, and we can maybe learn from what we did correctly to try to improve the process. The next control chart that we'll talk about is the C chart. Again, this is where we're looking at rates per unit. An example of this would be if I'm counting the number of defective components on a printed circuit board, or the number of defective pits, let's say, if I'm looking at a visual test, and I'm looking at counting the number of things on a single fixed unit. And again, a good example of this where you'll see is in a medical device. If I was to be making a catheter and I was to be looking at visual defects, I can count the number of visual defects I have on a given catheter that I am inspecting. Again, here the control chart looks just like a P chart. It's C bar plus or minus 3 times the square root of C bar. That's the formula based on the Poisson distribution. That gives me control limits. And this is an example where I have pass rate. And again, I could have done this as a first passing on a P chart, or I can count the number of acceptable product. So C bar here is 56.65, lower limit 34.07, upper limit 79.23. And as you can see, that this process is well in control, and there is no issue with our pass rate, no good lots, no bad lots. Okay. So that's sort of a quick, about a 10 or so minute talk about control charting. And again, if you want some more insight, I would, Douglas Montgomery has a very good book on quality control. Wheeler has a very good book on SPC. You can kind of get some more insight into it. But the whole idea of SPC from trending perspective is if you need to put some sort of statistical limit around a chart, SPC is the way to go. Another way of approaching trending is to do linear models and to do regression analysis. In a regression analysis, you basically create a model, y is equal to mx plus b, where you have 2 parameters you want to look at, the intercept, which is where the line crosses the y-axis, and the slope, which is the rate of change, that for every 1 unit increase in x, I get a slope unit increase in y. So here's visually what I'm talking about. This beta naught, the intercept, is where the line crosses the y-axis. And as you can see, for 1 unit increase in x, I get a beta 1 unit increase, or the slope increase in y. And so the steeper the line, the bigger the slope is. The flatter the line, the smaller the slope is. Typically, the way that we define a trend using regression is we look to see if the slope is significantly different than 0. If the slope is not statistically different than 0, that is that 0 is a possible value for the slope, we would say that there is no relationship between x and y. And in that case, we can say that there is no trend. And I'm going to go back a whole bunch of slides for a minute and show you something that people will do and kind of mix it. A lot of people will take this circled area and they'll say, let me fit a regression line. And even though I have 7 points in a row that are increasing, I want to know if that increase is significant. And they'll fit a regression equation to that and test to see if the slope is statistically different than 0. And if it's not statistically different than 0, they'll claim that they do not have a significant enough trend to warrant an investigation. So that is another way to look and use regression analysis as a methodology for determining a trend. The other thing to keep in mind is you also want to look to see if the intercept is statistically different than 0. An intercept of 0 would indicate that the line would cross between 0 and 0, and this is between, x equals 0, y equals 0. This is a very important piece to understand with trending, because in many cases, if the intercept is not equal to 0, that is indicative of a bias in the system, so that we might be less inclined to see a trend because the entire system is shifted up or shifted down from the origin. Okay. A couple of things about regression analysis I just want to mention. There are things like R-squared that tells you how predictive the model is. There are methods for looking at residuals, and then there are lack of fit tests that allow you to determine if the linear model is appropriate. I want to talk quickly about R-squared. R-squared is coefficient of variation, and it is it explains the proportion of variation explained by the model. You can increase R-squared in different ways, one of them being by adding more variables, another is by taking the averages of values instead of taking the individual values. And the problem with R-squared as a metric is that typically there's not a good R-squared. Again, if I'm using it for trending analysis, R-squared of 0.75 might be sufficient enough to claim a trend. And if I was doing it for comparing two methods, I might want it to be as high as 97%. So R-squared, from the purposes of trending, doesn't give me an awful lot of insight into what's going on. A residual is just the absolute difference between the observed value and the fitted value. So yi, in this case, is what I actually observed. Yi with a little hat on top of it is what's predicted by the model. That difference we expect to be small, so that we want the model to be very predictive of the data set. So residuals give us an ability to look and see if we have a certain point that is out of character or out of what's expected. Again, this is a way for me to look for a trend in the data set, because even though I might not have a overall trend, I might have an individual point or two that are very much different than the rest of the data set. A couple of things about the property of residuals. They do sum to 0. They are, if I take the variance of the residuals, that's the mean squared error. And the other thing to keep in mind is, even though residuals are not truly independent, for the purposes of doing any sort of analysis, it's sufficient to be, the interaction of the residuals is not an issue. One of the things I like to do is when I talk to people about trending analysis, if I'm going to look for a trend, one of the things I want to do is take the standardized residual, and that is to take each individual residual, divide it by the square root of the mean squared error from the regression analysis, and that puts me on a 0-1 scale. And then any standardized residual that's greater than 3 or less than -3 is an outlier. But in the world of trending, what that means is that's an individual point that is statistically different than others. So again, what we're talking about is using regression to build a model to say, I don't want to use control charts, I'm not using run charts, I'm building a model that Y is equal to X, where X could be time and Y could be the number of complaints, and I want to see if I have a particular month where my complaint rate is a lot different than other months, or I want to be able to look at the number of deviations that I'm writing. And then the whole idea is that if I can get a standardized residual that's quite large, that particular data point is much different than the other ones. Now, this whole idea of regression analysis is typically done in a retrospective manner. So I've collected a whole lot of data on, and I'll use complaints because that seems to be a very popular use of trending. And I want to go back and look to see if I had a trend historically in the data. I might not have been doing real-time trending analysis. Regression analysis is very handy. Okay, the other thing to understand is that once I do control charting, I can go back and from the range chart and estimate my standard deviation if I want to do some sort of capability analysis. So this just talks about the fact that there are constants D2 and C4 which allow you to take a range and convert it to a standard deviation, or take an S-bar and convert it to a standard deviation. We saw this before. This is just a chart that actually works through from the control chart we had before and shows you that even though the R-bar is 9.76, the standard deviation for that data set would be 4.2. That value of 4.2 is different than if I took the standard deviation of the 10 values that you see in the top chart, and because this is made up of 5 points for each mean, it's also going to be different than if I took the standard deviation of the 50 points. This is a way of estimating the standard deviation based on the observed range within each time point. Again, an example from control charting is that you can look at this example and fill out and go through the calculations and find out that, in fact, the control limits would be 172.8 to 184.2, and that the control chart for the range chart would be an upper limit of 20.68, and it would look something like this as a graphic. And that's the range chart. As I said to you, here are the SPC formulas. This is the A3 S-bar, A2 R-bar, control limits, and estimating the sigma from the range. And here is a table that gives you all of the values that you would expect to see. So here's the last piece, okay? So I spent the first about half hour going through control charting, regression analysis, examples of control charting, giving you the formulas, giving you the constants. And at the end of the day, the reality of trending is that trending is something that is very specific to your company and to the data set that you have. And every company has different challenges with doing trending analysis. So I want to give you a compilation of a couple of different problems that I've seen with organizations that do trending and how we can come around it. The first thing is that in many cases we try to trend things that there's a lag between the things that we're trending. So, for example, we're looking at doing complaints and we want to do complaint rate. Well, if we want to do complaint rate, that is number of complaints per $1 million of sales or number of complaints per million units sold, if I sell a unit today on February 26th, what does that mean? The complaint is not coming in on February 26th. I might not see that complaint until sometime into March or April. So I need to normalize back out by lagging, and typically what I tell organizations to do is take the average sales over the last year as your denominator, and then I can count the number of complaints I got in February of 2013 and divide it by the average sales from February 2012 through January of 2013. And then I move that 1 month up. So when I do March, I I do March of 2012 through February of 2013. I just keep moving. So that is a way for me to be able to do something that's called a moving average. I'm moving and averaging my sales. Another issue that you run into is when you have very small number of sampling points, so that you might not be collecting data on a monthly basis. You might be collecting data on a quarterly basis. And so, if I waited for 20 data points, that's 5 years of data. I don't have 5 years to come up with. So in many cases, we have a big problem. And another problem that you would hear about is where you have very low rates. So I have, and it's the last bullet point, and I'll get back to this, is where I have very low rates. So month after month, I have zero complaints, zero complaints, zero complaints, zero. And if I did any sort of statistical analysis, or even when I talked about trending analysis and things like that, the first month that I get a complaint is going to be a trigger. It's going to set off bells and whistles, because my average complaint is less than 1. And so anytime I get a complaint, it's going to trigger a problem. So we'll talk a little bit about how to get around that in a minute. The other thing to keep in mind is that when you're doing trending analysis with high variability data, it's very difficult to see the signal from the noise. So if you have a very noisy system, you usually tend to use moving averages. So you might, if I can have tremendous fluctuation month to month in my rates, instead of looking at reporting out into any sort of trending on the month, I might do a 6-month lag. So I might take the average of the last 6 months. Now, of course, what's going to happen is I'm going to smooth out that variability, and now I'm looking for 5 consecutive months in a row that are increasing with this lag function. What does that mean? That means that I've taken out all the noise, and that if I'm increasing in 5 consecutive months, I must have a rate that is increasing underneath all of the noise. So we'll talk a little bit about those, and I kind of went through them quickly, and I'll give it to you more explicitly. When trending a process where data is collected as a function of past data, like complaints, coming and comparing it, one of them is to complete a ratio where the denominator is lagged, like I spoke to, or the other is to look at the complaint rate and average it by using a moving average. So it's either you take the average of the denominator, or you can take the average of the complaints per month and do that over a 6 or 12-month period. So here's an example of complaint data where I'm going to lag. So in the upper right here, what you see is an example where I have unlagged data. Here's an example where all I've done is I've taken that same data set and I've lagged it by 1 month. So this is where I am now looking at comparing, just to be clear, I'm comparing the complaints from this month back to the sales from the previous month. 3 complaints here, 300 sales the month before. So I'm lagging my sales to the month previous to the complaints that I'm counting. Or, as I said, I can just take the average of 3 months, and that's what you see here. This is the average. 1.3 here is just the average of 1, 2.7, and 0.6. So I can do an unlagged, I can lag my sales by 1 month, or I can look at my metric, my complaints per million units sold, and lag, and do a moving average of 3 months. These two, the lagged and the 3-month, are the proper things to do. The unlagged example is not a good example. It is not a good way to present your data. What do you do when you have small sample sizes, low number of opportunities that are in your data set? How do you deal with that? This is a common problem, again, that you'll see. And there's different ways that we look at this. You can pool data over multiple points. Again, you can look at Instead of, if I have 0 complaints and then I have 1 complaint, I can just take the average with that moving average. But again, I don't particularly like that as an approach. What I do like to do is actually count the number of, and whatever the time point is, we could do number of days, number of hours, number of months between events. If I am seeing an increase in the number of months between events, then I'm starting to see a trend in my data. The example of this is very easy. I don't see complaints at all, right? So I go for 12 months, I don't get a complaint. In month 13th, I get a complaint. Okay, I'm not going to react to that yet. I just had 13 months between complaints. If the next time I see a complaint is 6 months later, I'm starting to say, typically I see it 13 months apart. Now I'm seeing it 6 months apart. I wait to that next one. If that next one is less than 13 months from the last one, that's a trend. So I'm seeing 13 months, then 6 months later, and then sometime less than 13 months. That is a trend because my frequency of events is increasing, and that is an indicative of a problem. Okay, so here's an example where I'm going along, 5 months between events. I keep going along. I get 5 months again between events, and then the next month I get another event. So I go 5 months, I'm averaging 5 months, now I got 1 month. If my next point after this is less than 5 months, that to me is considered a trend, and that is something that needs to be investigated. We talked about high variability. One of the things you could do is smooth things out. Easiest to show you with an example. If I'm trying to do some sort of trending of sales, this is very common with the marketing folks and the sales folks. They like to look to see if trends, if their data is, if their sales are increasing. The problem is that there's so much noise in the data that if I do any sort of statistical analysis, I'm not going to be able to see anything because the variability is so big that in order for me to get anything to trend, I'd have to have an astronomical data set, an astronomical quarter of sales. So you could do something called an exponentially weighted moving average. You could just do a regular moving average. You could do a whole bunch of different things with this data set that allows you to smooth out the variability that you see month to month. What do you do when you see a spike in your data set? If you know that you got a spike and that spike is an outlier. Now, what do you mean? What do I mean by it's an outlier in the data set? Here's an example. And I keep coming back to complaints because this is something I dealt with personally. We were averaging about 25 complaints in a month. 25, 27, 32, 21. It kind of is in this about 25 plus or minus 5 to 7 complaints in a month. And in 1 month, we got 75 complaints. Now, if we kept that month with 75 complaints in the data set, one, we would have had a high variability, so it would have inflated any statistical analysis we did. But the thing about it is we went back, we said it's a trend, it's an out-of-control situation, special cause, let's look for an assignable cause. We found the assignable cause. When we did that, we removed that month from all future calculations because it was a special month. Something special occurred. In our case, it was a particular lot was released that caused a lot of complaints, and that caused us a lot of consternation. Another thing you can do when you have spikes in your data, and you know you might have months where it spikes, so you have seasonal effects. A good example is for us to kind of think about is in the retail business. You're going to have seasonal effects around the holiday season. When that happens, you can smooth your data using something like the exponentially weighted moving average or some other moving average. Or what I tell people is if you get a spike in your data, get 75 complaints, okay? You know it's a special cause. You could take it out. You could do all those nice things. But I'm waiting for that second spike. And when I see a second spike in the data set, that's when I typically say This is no longer a spike in the data set. This is something systemic in our process. So that, we have one lot that was bad, okay, got 75 complaints. If I am trending complaints and I see another month that goes up to 75, and I go back and I say, oh, look, it's another bad lot. I can't keep those two events isolated. I have to understand that that's a trend, that there's a problem in the data set, that on a regular basis we make one bad lot, it gets out there. When it gets out there, it generates a lot of complaints. Now, why is that important? Because in this case, if I'm doing real-time analysis, I'm not going to wait till I get to 75 complaints to take action. I'm going to say that I'm going to put in some sort of limit that once I get to maybe 35 or 40 complaints, then I'm going to recall that lot. Because the complaint rate is much higher than it should be, there's a trend out there in the data set, recall that lot in so I don't get all of those complaints, I don't get that spike in the data. So understand that trending is just more than plotting data over time. In many cases, it really requires the right analysis for the situation. If, in fact, you're going to be looking at normalizing a particular metric to sales, how do I come up with the right way to normalize sales? Do I look at taking the moving average of the metric, or do I take the average sales over the last 12 months? And how do I go about doing that? How do I create statistical limits that are meaningful, that when it goes out of those limits, I'm going to take action? Because ultimately, I want to find a trend before it becomes a problem. You want to nip it in the bud. And always, and this is, management struggles when I say this, but I truly believe this to be the case. I am much better pulling in a lot from the field through a recall or a voluntary action than I am to allow a number of complaints and just cause that and say, well, that was an aberrant lot, that was an aberrant or a trend in my data set. I'm better off taking the action before it becomes a problem, because the data talks. If you know what your average complaint rate is, you know what your average first pass acceptance is, you know what your average is, you know what your statistical variability is. When you start to see points that are outside of those limits, you need to start to take action. And no trending analysis, and this is the key takeaway point before we open up for questions, is that no analysis you're going to do is going to be meaningful unless you have an action plan in place. So doing trending analysis because it's required by some, QSR or some other CFR type thing is meaningless unless you have an action plan to fix the problem. And with that, I'm going to turn it back over to Samuel to open up for questions and answers.
Thank you, Stephen. It was a wonderful presentation, and I thank all the participants for cooperating with us. It is time for the Q&A to begin, and we request all who have questions for our presenter to click on the Raise Hand option, which is a palm-like icon at the bottom of your participants panel, to ask your questions verbally, or post your questions in the Q&A panel so that our presenter can read it out loud and then answer. For any reason, if you're unable to ask your question using either of the two means I mentioned, please share it with me by chat and I shall pass it on to our presenter to answer. Meanwhile, we sincerely request you to share your feedback in the feedback form that will appear on your screen in the polling panel right now. The feedback has just 8 questions, mostly multiple choice in nature, and it wouldn't take more than 2 minutes of time to answer. The polling will remain open till the end of the session, and you can answer it even after the Q&A is over. We'd be grateful if you could stay back a little longer and complete this feedback for us. On the screen, you can see the past webinars of Stephen Wolfish. If you would like to purchase any of these webinars in the recorded version, you can log on to www.globalcompliancepanel.com. And also, I would like to inform you that today's webinar will be available in the recorded format so that you can inform your team members or colleagues or friends if you think they might benefit from this webinar. And we have an upcoming webinar of Stephen Wolfish on 12th of March 2013. If you'd like to take part in this webinar, you can log on to www.globalcompliancepanel.com. And to know more information of our webinars and Stephen Wolfish's webinars, you can follow the link which is shown on the screen. Stephen, I do not see any question coming up as of now. Shall we give another 30 seconds for them to think and ask questions?
Sure, that's fine.
Thank you. Also, Stephen, I would like you to give any concluding remarks or feedback if you want to give it to the attendees, pass to the attendees. So before we end the session, if you have anything to say to the attendees, you can just let them know about it.
Yeah, so let me kind of, like I said, I finished with my statement about, you need to have a good action plan, and I do believe that. Two things. One is obviously if you do have questions, feel free to reach out and send them to Global Compliance Panel. They will get it to me. But the second thing to understand about trending analysis in general is that when you are trying to trend data, you want to make sure that you're doing it in a fashion that's consistent with other metrics and other analysis that your organization does. So if you have quarterly or monthly metrics or management reviews, make sure that your trending analysis complements that and it doesn't contradict what's going on. So someone's asked a question on slide 26. It states that we test if the slope is statistically different, what is considered significant. The part that I should have expanded on there, and thank you for the question, is that when I say that it's significant, I'm talking about statistically significant when you use a regression analysis. So if the p-value, the probability of it being by chance alone, if that's less than 0.05 or 5%, we call that statistically significant.
Thank you, Stephen. So we'll give another 10 seconds for them to ask questions. Stephen? So, Stephen, I do not see any question coming up as of now. I don't see any more questions.
Right.
So, shall we conclude the session and end the webinar?
Yep, we can definitely do that.
Thank you, Stephen. We are grateful to all of you for having taken part in this webinar. If you'd like to get in touch with us, you can send us an email to webinars@globalcompliancepanel.com. We welcome your suggestions and feedback or ideas on how we can improve our webinars. If you'd like to suggest a topic or desire a customized corporate training, online or on-site, we ensure that whatever is your training necessity, it will be a priority. We look forward to having you with us again sometime soon and for your continued patronage. On behalf of our presenter, Stephen Wolfish, and the Global Compliance Panel team, I would like to say thank you for participating in this webinar and we wish you a great day ahead. Thank you. Thank you, Stephen.
Thank you very much. I appreciate everyone's time.
Thank you very much.